Today we are going to be graphing sums and products. So it's just what it sounds like. I'm going to give you two graphs and you need to either sum them or add the two graphs together, or product would mean that you need to multiply them together. So example number 1 here says to draw the graph of f of x plus g of x using the addition of ordinates. So f of x is the blue graph, g of x is the red line that you can see there. So the first example that we do here, I'm going to do this with a table, and you can see the table down here below. What I'm going to do is I'm just going to go from the left-hand side of my graph, and I'm going to choose some x values to look at. So -4, I don't really have any graph over there, and -3 doesn't really work either. So I'm going to start at -2. And then I'm going to go to -1. And I would like to go to 0, but there is some interesting things happening in here at -0.5. So if you see any points where the graphs intersect, that is a good point to include. So let's include -0.5 in here. Then go to 0. To keep it symmetrical now on the other side, I'll do +0.5, 1, and 2. So there's a few extra spaces there in case you wanted to test some other points as well. Now for f of x, we're just going to go across using that blue graph, and we want to read off the y values when x is -2. So when x is -2, the y value for f of x is here at 6. At -1, oh, it's right on the axis there, y would be equal to 0. At 1/2, so half, we're at this point here, which would be about -1.5. At 0, the y value is -2. At 1/2, well, this is a parabola, this is going to be symmetrical. So at +1/2, we're going to be at -1.5 again. At 1, we're at 0. And at 2, we are at 6. Now we want to do the same thing for the g of x line. So using the red line there, when x is -2, we're down here at -6. At -1, the y value at -1 is there, which would be -3. At -1/2, we're at -1.5. At 0, we're going through the origin, so that's 0. At 1/2, we're coming up here to be at 1.5, +1.5. 1 is 3, and 2, the y value is 6. Now, if you are careful by putting your points into that table, all we now need to do is to add them together, f of x plus g of x. So that's 6 and -6 is going to make 0. So makes sense. It's evenly spaced above the axis, +6 up and -6 below. So when I add them, it makes 0 in between. If one of the values is 0, like in the second set of values here, then when I add them, I'm just going to get the -3. -1.5 plus -1.5 also makes -3. -2 plus 0 is -2. -1.5 plus 1.5 makes 0. 0 plus 3 is 3, and 6 plus 6 is 12. So I'm going to use a different color to sketch those points on my graph. So at -2, I'm at 0. At -1, I'm at -3, which is right here, because remember that one was 0, so it didn't actually move anywhere. At -1/2, we're all still down at -3. At 0, we're at -2. At 1/2, we're at 0. At 1, we're at 3. And at 2, we are way up at 12. So we're going to get a curve that's going to come down through all those crosses. Even though it looks like there's a bit of a flat spot here, it's not flat, it's going to curve through like that. And that was what happens when we add those two curves together. Now that's been done with a table, and you can always use a table to make sure that you're accurate and careful, but perhaps you might want to try doing it without a table as well. So I've got a second example here, if you're feeling confident. The diagram to the right shows the graph of y equals f of x, and where f of x is equal to x squared. And we also have g of x, which is the line x. So we want to, on the same set of axes and in a different color, sketch f of x plus g of x by adding the ordinates. So I'm going to start on the left-hand side of my graph. I'm going to start here at x equals -1. The parabola is 1 above, and the line is 1 below. So 1 plus -1, they're going to cancel each other out, and I'm going to get a cross on 0. Then let's go over to 0. Both of the graphs are at 0, so 0 plus 0 is 0. Now, 1. Parabola's at 1, line's at 1, so 1 plus 1 makes 2. And we could try to keep going. We don't really have accurate values past that. The straight line is at 2, but the parabola would be very, very big, which we know would be 4 because 2 squared is 4. So it's going to be way up high here at 6. So it's going to be coming down through these crosses. We don't really have a flat spot there because if we had a look at these values, there is more space on the negative side than there is above for this spot here. So we're going to come slightly below and back up like that. Okay, and that's what our graph looks like when we add those graphs together. Question 3 says sketch y equals square root of x and y equals x minus 1 on the same set of axes. Okay, so y equals square root of x. We're going to use this space to draw a lovely big graph. Okay, so have a think about what does the graph of square root of x look like? Well, we know we cannot square root negative numbers, so we're not going to get any part of the graph over here for my negative values for x. The first value that I can sub in would be 0. The square root of 0 is 0, so it's going to start here at the origin. If I go to 1, the square root of 1 is 1. And to be sneaky, I'm going to sneak down to 4 now. Square root of 4 is 2. So this is actually making part of a sideways parabola. Okay, so that's my y equals square root of x graph. Now on the same axis, I want to draw y equals x take away 1. That would be a straight line. The y-intercept is -1. And the gradient would be a +1, which means rise 1, run 1. And I could rise 1 and run 1 again. I could do a few of these, but you really only need 2 points on a line, and then you can just connect them up. Oh, that's a little bit wobbly there. And there is my straight line for y equals x take away 1. Okay, so we have sketched both of the graphs. We have a point here where they're going to intersect, which is not at 3, it's a little bit below 3, because we can see that 3, we're actually at 2 for the straight line, and we don't get to 2 on the sideways parabola either until we're at 4. So about 2.7 perhaps, somewhere in there. Anyway, we want to, in part B, sketch y equals x take away 1. Well, that was the straight line that I just drew. And then I have square root of x, which was that first sideways parabola that I drew. And the way that equation is written, they're next to each other, which means that I'm multiplying them together. So I want to go and multiply the points going across from left to right of those two graphs. Now, because the graph of square root of x doesn't exist on the left-hand side of the y-axis, then the product of those two graphs is not going to exist there either. Both of the graphs have to be present. So, starting at x equals 0. At x equals 0, I'm multiplying the y value, so it's 0 times by -1. 0 times anything is still going to be 0, so it's going to start here at the origin again. Let's move along to where x equals 1. We have one graph at 0 and the other at 1. 0 times 1 is 0 again. Now that does not mean there's a horizontal line joining those two crosses up. What would be happening in between? Well, if we just estimate a couple of values here, the straight line looks like, if I go halfway in between, would be at -1/2, and the parabola is probably at about 0.7. Either way, I'm multiplying a positive number with a negative number, which means that I'm going to get a negative result. So it's going to come down below. So you could type in, if you want to be a little bit more accurate, you could use those approximate values that I used. So -0.5 times 0.7 is about -0.35. So not very big, but it is negative down below here. So I'm going to bend down like that. Let's keep going up to when x equals 2. So we have 2 times by about 1.5. So that's going to be at about 3. Then 3, we've got two values. They're both above 1. As I multiply them, they're just going to keep getting bigger and bigger. So my curve is just going to come up, and it's going to get steeper and steeper as I go up that way. All right, so that is the graph of that one. On the next page, here is a bit of a summary of some of the properties that we have come across. So by sketching the sum of two functions, f of x plus g of x, it says here the first thing you should do is always add the ordinates wherever possible. This is the main idea, but there are some systematic approaches that you can use. If one curve has a 0, then when you add them together, it's going to be the value of the one that is not 0. If the curves meet, then the two ordinates are double whatever the y value is. Okay, so you can see it's all in there. It is a little bit wordy, but you can read through all the properties. That's for summing the two functions. Here's another one here for if you are subtracting the two functions. And then we have another summary here for multiplying, but we have covered most of those properties in the examples that we did. So let's go on to example number 4. Well, one more question here to do. We're going to find if f of x equals 1 over x and g of x equals 1 over x plus 2, sketch each function on the same number plane. And then in a different color, we want to sum them, f of x plus g of x. Okay, so the first equation that we're given, f of x equals 1 over x. Because it's a fraction and we have an x on the bottom, we know that the denominator cannot be equal to 0, which means at x equals 0, that would make my denominator 0, there is going to be an asymptote. So I'm just quickly drawing up my Cartesian plane here. At x equals 0, down here, I'm going drawing in my vertical asymptote at x equals 0. Now the horizontal asymptote for all functions in this form is always at y equals 0. To show that, to prove that, you would be looking at what happens when x approaches infinity. If x was infinity or a very big number, 1 divided by a very big number is going to be very, very tiny. It's going to be approaching 0. It won't actually get to 0, which is why it's an asymptote, but very, very close to it. So that's why I have a horizontal asymptote at y equals 0. Now, because my asymptotes are on both of my axes, I'm going to have to substitute in some values to get my curves here. So let's start with x equals 1. At x equals 1, into that formula, 1 over 1 is 1. Then let's sub in 2. 1 over 2 would be a half. And if I could go down to 4, 1 over 4 would be a quarter. How about we try a fraction? Let's try a half. 1 divided by half will be 2. And you see here is the first half of my hyperbola, approaching those asymptotes. What if we go to the negative side? If we sub in -1, 1 over -1 is -1. If I sub in -2, 1 over -2 is -1/2. If I sub in -1/2, 1 divided by -1/2 is -2. So I haven't done as many points, but there is the second half of my hyperbola. Okay, moving on to the second graph. This is the g of x equals 1 over x plus 2. The x plus 2 on the bottom, remember whatever makes the denominator 0 is where the asymptote is. So that would be when x equals -2. So I'm going to have another asymptote, which I'm going to draw in red over here. This is a vertical asymptote at x equals -2. And we are going to sketch the rest of the graph around that. I would still have the same horizontal asymptote, so I'm not going to draw that again. Still at y is equal to 0. So let's sub in -1, just going to the right of that asymptote. -1 plus 2 is a +1, so 1 over 1 makes 1. And this hyperbola is going to have the same steepness as the last one that I did. If I go to 0, it's 1 over 2, so that's at a half. And if I went to -1.5, it's going to be up here at 2. And here is my first half of the hyperbola. If I go to the left side of the x equals -2 asymptote, so I'm going to go to -3. -3 plus 2 is -1. 1 divided by -1 is -1. If I go to -4, it's going to be -1/2. If I went to -2.5, it's going to be at -2. Subbing in some values, getting my other half of the graph. Okay, so here's the fun part. I have both of my graphs and I have some asymptotes on there too. Now I want to add those two curves together. Now, there's 3 main sections to this graph. There is the sections that are divided up by those vertical asymptotes. So first of all, I'm going to start with what is happening with the graph on the left side of the x equals -2 asymptote. So this point here, the -3 at -1, that's kind of a key area there. I could add that with the little bit of the other one. There's 2 little parts there that would add together. So it's like -1 minus a little bit more there because it's negative there as well, would just come a little bit more below. This value here is at -2. There's another little negative bit from the other graph, so it's going to be slightly below down here as well. And even though this is from my y equals 1 over x hyperbola, even though it's very, very small as it's coming out along to the left here, it's always just going to add on just a little bit more going down underneath the other graph. So the first part is going to look like this, just slightly below the other one. Then I'm going to skip the middle part for a second. I'm going to do the part on the right hand side of the x equals 1 asymptote, because it does a very similar thing. The there's a very small part of this graph that needs to be added on to the other one. So just going to raise everything up a little bit. So this one will be a little bit higher. This one will be a little bit higher. Everything's just that little bit higher from being added on from the other graph. So it's going to come around like that. Now for the middle part. A key spot is at -1, because at -1, one of the graphs is at +1 and the other one is at -1, which means when I add them together, it will go through 0. If I come across a little bit, you can see that I'm quite a long way above on just to the left of that point, only a little bit below. So it's going to be coming up on the positive side. And as I get closer and closer to that x equals -2 asymptote, my y values for the top curve are getting very, very big, but the one below is only quite small. So it's going to be getting very steep up here very quickly, but never touching that asymptote. It's going to curve around. And the same thing going down the other way. The negative version this time is getting very, very steep very quickly, while the positive values are getting very small. So it's going to be coming down like this. So let's draw a curve coming down, doing a little bend and down through there, never quite getting to those asymptotes. And that's what my graph would look like. Okay, so you need to have a go of sketching some sums and products in exercise 5D.